Lesson 42, the chi-squared goodness of fit test. Example 2. The manager of a Round Table pizza parlor kept track of the number of pizzas sold at his restaurant each day for an entire week. That week, 54 pizzas were sold on Sunday, 67 on Monday, 49 on Tuesday, 52 on Wednesday, 55 on Thursday, 73 on Friday, and 78 on Saturday. Test the idea that the number of pizzas sold at this Round Table pizza parlor is the same for each day of the week. Based on this result, what could the manager of this restaurant conclude? Well, to answer this question, based on this result, what could the manager of this restaurant conclude? We need to know the result of testing the idea that the number of pizzas sold at this Round Table pizza parlor is the same for each day of the week. Now, if the number of pizzas sold is the same for each day of the week, one would expect that each day of the week would account for 1/7 of the total number of pizzas sold that week. The chi-squared goodness of fit test is used to determine if the expected frequencies, according to the idea that the number of pizzas sold is the same for each day of the week, fit the observed frequencies, which is the actual number of pizzas sold that week. So this chart takes us through the steps of conducting a chi-squared goodness of fit test, starting with stating the hypotheses. In a chi-squared goodness of fit test, the hypotheses HO and H1 are always stated in the same manner. HO is that all of the expected frequencies fit the observed frequencies, and H1 is not all of the expected frequencies fit the observed frequencies. Next, we state alpha, the level of significance. Here we'll be using the customary alpha of 0.05. Now we could use the TI-84 calculator's chi-squared GOF test command to calculate the p-value required to reach the decision. To do this, we need to enter the observed frequencies or data values into list 1, and then we need to enter the expected frequencies into list 2. So looking at the sample data, we found that 54 pizzas were sold on Sunday, 67 on Monday, 49 on Tuesday, 52 on Wednesday, 55 on Thursday, 73 on Friday, and 78 on Saturday. These data values will be used as our observed values in our chi-squared goodness of fit test. Now we need to generate the expected frequencies according to the idea. The expected frequencies are calculated by taking the n, the total sample size, times p, the predicted proportions. Here, the idea is that the number of pizzas sold each day of the week is the same. Thus, 1/7 of the pizzas sold for the entire week should be sold individually on each day of the week. So here, the expected proportion is 1/7 for each day of the week. We multiply this proportion of 1/7 times n, the total sample size, or total number of pizzas sold that week. We find n, the total sample size, by adding or summing up all the observed frequencies. So if we add the 54 plus the 67 plus the 49 plus the 52 plus 55 plus 73 plus 78 equals a total of 428 pizzas sold at that restaurant that week. So taking the n, the sample size of 428, multiplying it by the proportion of 1/7, we'll calculate the expected frequencies according to this idea. So now we can enter these values into the lists in the TI-84 calculator. To do this, we press Stat and Enter to enter the list editor. Then we can arrow up to the list names and press Clear Enter to clear out the lists of old data to make room for the new data. In list 3, we can enter in the claimed or predicted proportions. In this case, the 1/7 for each day of the week. So 1/7 can be entered by typing in the 1 divided by the 7. So we enter the 1/7 for each of the 7 days of the week. Now we can calculate the expected frequencies by taking this proportion and multiplying it by n, the total sample size. To do this, we arrow over to list 2, arrow up to the top of list 2, so L2 is highlighted, and then enter in the 428 times list 3. Enter. we expect to sell about 61.14 pizzas every day if it was the same each day of the week. Now in list 1, we can enter the observed frequencies. So we enter the 54 for Sunday, 67 for Monday, and so on. 49, 52, 55, 73, and 78. Now that we have our observed frequencies entered in list 1 and the expected frequencies entered in list 2, we can continue with our chi-squared goodness of fit test hypothesis test procedure. To do this, we need to execute the chi-squared GOF test command. The chi-squared GOF test is conducted with C minus 1 degrees of freedom, where C represents the number of categories involved. In this case, when we're talking about the number of days in a week, we have C equals 7 days in a week. Minus 1 gives us 6 degrees of freedom. Now the chi-squared GOF test command is found by pressing stat, arrowing over to tests, and then arrow up until the cursor is next to chi-squared GOF test. Press enter. We enter the observed values in list 1, the expected values in list 2. We have 7 categories, minus 1 degrees of freedom. Enter is 6 degrees of freedom. And then calculate, enter. So here, the chi-squared GOF test command on the TI-84 calculator has calculated the p-value for us. Rounding the p-value off to 3 places after the decimal, we find that the p-value is approximately 0.047. So now we could use our p-value to make our decision. Since the p-value of 0.047 is 0.05 or less, the decision is to reject HO. And when we reject HO in a chi-squared goodness of fit test, this leads us to the conclusion that not all of the expected frequencies fit the observed frequencies. So, based on the results of this test, we can make the following statement. Therefore, not all of the expected frequencies fit the observed frequencies. So, based on this result, the manager of this restaurant could conclude that the idea that the number of pizzas sold at this Round Table Pizza Parlor is the same for each day of the week is not valid. Now, the result of the hypothesis testing procedure only leads us to the conclusion that the number of pizzas sold at this Round Table Pizza Parlor is not the same for each day of the week. To see how they're not the same, we need to look inside the data. So here, we see that if the number of pizzas sold at this restaurant was the same each day of the week, we'd expect to sell about 61 pizzas. But if we compare to what we actually observed, there were more than expected pizzas sold on Fridays, Saturdays, and Mondays, and fewer than expected pizzas sold on Sundays, Tuesdays, Wednesdays, and Thursdays. So therefore, we can make the following conclusion. The data indicate that this restaurant sold more pizzas than expected on Friday, Saturday, and Monday, whereas on Sunday, Tuesday, Wednesday, and Thursday, fewer pizzas were sold than expected. Here, the manager can use the results of this hypothesis test in order to make decisions regarding staffing or inventory.